Hello learners! I am Benjamin Franklin, your guide today on our journey to understand the concept of irreducible quadratic expressions and their application in partial fraction decomposition. We will be exploring this concept and applying it to solve an integral. I promise this will be a fun and engaging journey, so buckle up. Simple quadratic factors. To start our journey, let's lay down some key concepts. 1. Irreducible quadratic expressions. A quadratic expression, a, x squared plus bx plus c, is irreducible if the discriminant, b squared minus 4, a, c, is less than 0. 2. Partial fraction decomposition. For a rational expression that has a denominator with an irreducible quadratic factor, we use partial fraction decomposition. We decompose the expression with a partial fraction whose denominator is that irreducible quadratic factor and the numerator is a, x plus b. 3. Solving for coefficients. We solve for the coefficients a, b, and c by equating the numerators after getting a common denominator. 4. Substitution and integration. Finally, we substitute these values back into the integral and solve it. Alright, now let's see each of these concepts in action with an example. Evaluate the integral of 2x minus 3, all over, the quantity, x cubed plus x, with respect to x. The problem asks us to evaluate the integral of a rational function. Let's jot that down. Since the degree of the numerator, 2x minus 3, is less than the degree of the denominator, x cubed plus x, we decompose the given rational expression into partial fractions. Firstly, we need to factor the denominator. Then, we proceed with partial fraction decomposition. Since the denominator contains the irreducible quadratic factor, x squared plus 1, we include a, x plus b, all over the quantity, x squared plus 1 as part of the decomposition, along with c over x for the linear term x. Next, we equate the numerators, after getting a common denominator. Now, we solve for the coefficients a, b, and c. After solving, we find that a equals 3, b equals 2, and c equals negative 3. Thus, then, we substitute these values back into the integral. Finally, we solve the integral. Splitting up the integral. Then evaluating each integral. Note that we may rewrite the natural logarithm of the absolute value of the quantity, x squared plus 1, as the natural logarithm of the quantity, x squared plus 1, since x squared plus 1 is always greater than 0. Now we can display the answer. The integral of the given function with respect to x is equal to 3/2 times the natural logarithm of the quantity, x squared plus 1, plus 2 times the inverse tangent of x, minus 3 times the natural logarithm of the absolute value of x, plus the constant of integration. Well done, everyone! We have journeyed through the concept of irreducible quadratic expressions and partial fraction decomposition successfully, and I believe you have grasped the essence of this concept. Now, it's time for you to apply this knowledge and practice more problems. Remember to enjoy the process as much as the solution. Until next time, happy learning!